So when we're solving a right triangle, the idea is with a minimum amount of information, we can figure out everything else. Okay? So usually part of the minimum amount of information would be, okay, well, it's a right triangle. Kind of good to know, right? Because all the trig stuff we know, Pythagorean theorem, that's all for right triangles. So we want to know that it's a right triangle. And then we're going to have to know a little more than that, I think. Okay. What else do you think we might need to know? Say it louder. One of the two angle measures would be nice, wouldn't it? Okay. If we knew angle A right here, do you think we could figure out angle C? Yeah, because we know A and C, we know their sun's 90, don't we? Okay, so that would help. Now let's say we did know this angle right here, and we figured out what angle C is. Would that help us find the length of a side? It wouldn't, would it? Okay, we'd still need another piece of information, wouldn't we? Okay, so I just want to start with, let's say we know this is 32 degrees right here, and just one of the three sides. It doesn't really matter which one. I'll just say this one's 8. Would that be enough for us to finish solving this? And what that means is find every missing angle and every missing side. Of course, we can find this other missing angle, can't we? What's it going to be? There you go, 58. Okay, and then, okay, you can't find both these at once. You can't find the hypotenuse and this adjacent, I'm looking at this angle, adjacent side. Okay, you can't find them both at once. So which one do you want to find first? Yeah? Okay, so let's find x first. So what function are you going to use? Okay. So the sine of 32 degrees equals the opposite over, oh wait, that's tangent. The tangent of 32 degrees equals the opposite over the adjacent. So what does x equal? Okay, 8 over the tangent of 32. So we can get out our handy dandy calculator here. 8 divided by the tangent of 32 degrees. 12 point, we're going to have to round that off and say 12.8. Okay, now something to remember, I just rounded this off to 2 decimals because it was 12.802, so it really rounds off like this. Now I'm going to use that to find the hypotenuse. Okay, let's say I use the Pythagorean theorem. If I use this number that I just rounded off to 2 decimals and use the Pythagorean theorem, so I'm 12.80 squared plus 8 squared equals AC squared. How accurate will this answer be? Right? 1 decimal. Righto? We rounded this one off to 2 decimals. We use it in another computation. That new answer, only 1 decimal point of accuracy. Now we could use something different. We could say, well, if I screwed up finding this and then I use it to find the hypotenuse with the Pythagorean theorem, that could be bad. So maybe I'll use the sine function. So that's opposite over hypotenuse. I'll just say h for hypotenuse. So the hypotenuse then would be 8 over the sine of 32. And that way I don't have to use something I found to find something else. When my calculator does this bit, it's going to round it off to 9 decimal places. So my answer should be plenty accurate to 2 decimal places, shouldn't it? Yeah? Okay. So that's solving a right triangle. Now it kind of depends what you have. So let's say you only have 2 sides. This is 10 centimeters This is 20 centimeters. Is that enough to solve this right triangle? Just two sides. What do you think, guys? Can we find the third side? How? Pythagorean theorem? Who says Pythagorean theorem?
Teachers, would you send the soccer team over to the little theater for their COVID testing? You send soccer to the little theater.
All this COVID testing, you guys are just getting dumber and dumber, missing all this stuff, aren't you? Okay, so Pythagorean theorem, everybody agrees we can find this missing side, which I'll call M for missing side. What about angles? Okay, can we find angles? Okay, so you got to figure out which angle am I going to look for first. So maybe they're labeled here. You want to find A or C first? A? Okay, so I'm going to find angle A first. So I have to think about, as I'm looking at angle A right here, what are the two sides I know? What's 10? You understand? Opposite. There you go. And what's 20? Hypotenuse. Right. And so what function is that? Opposite and hypotenuse. Yeah, there you go. So the sine of angle A equals the opposite over the hypotenuse. And that's a half, by the way. So the sine of angle A equals a half. And if you guys do that on your calculator, what button do you have to hit first? Yeah, second function, right? Second function. Now, I know that the sine of 1/2, or I know the sine of 30 degrees is 1/2. I think I got that one memorized. Because I'll run for a calculator. Am I right? Am I right, Yost? Okay, so this one's, so that means the measure of angle A is 30. Everyone make that work? What about the measure of angle C? 60. Hey, wait a minute. This is a 30, 60, 90 triangle. Did anybody see that? Who saw that right off the bat? Oh, it's a right triangle. The hypotenuse is 20 and the short leg's 10. So that's that 1 to 2 relationship, isn't it? So what's the long leg, guys? 10 radical 3. Yeah. And if you see that, see, when I see this, this relationship is a 1 to 2 relationship on a right triangle, that's got to be a 30, 60, 90 triangle. So it's okay just to solve it because we know that's how it works. And of course, what about this one? No. I don't even know if you guys can do this, but we're going to give it a shot. I'm just going to make life easy here. Do you guys recognize what type of triangle this is? 45, 45, 90, isn't it? It's got to be. It's an isosceles right triangle. It's a 45, 45, 90. So can you all tell me what, well, we know that the angles are 45. And how long is angle X, or side X? Yeah, it's 5. It's 5 units. So we don't always have to use trig. I guess we're still using trig here, but we're using the similar triangle thing. So here, I want you guys to practice up on one. Oh, let's say the hypotenuse is 109. That's a right angle. This is 91. We'll call this one J, H, G. Okay, so can you solve this right triangle for me? Find all the missing sides, find all the missing angles. You guys getting the same answer I'm getting? So did anybody do it like I did? Did anyone think cosine? Who thought cosine? So when I looked at it, the first thing I saw was adjacent and hypotenuse. Okay. Now we could have found this angle first, couldn't we? And then we would use what? That'd be sine. Anybody use sine first? Awesome. Okay. So that either one of those things works, and I think that's great. Now the other thing I'm thinking is to find this missing side. I'm probably not going to use this angle to find that missing side using like the tangent. The tangent of that angle equals our missing side over 91. I'm probably going to use the 91 and the 109 in the Pythagorean theorem, which are two things I already know. So here it is. I subtract 91 squared, which is fine as long as I don't, I got to make sure I just square them first before I do the subtraction. So when I actually type that in my calculator, it looks like this. So when I hit enter, it's going to square them first, then do the subtraction, right? Okay. And then what do I need to do with this number, 3600? Right, raise it to the 1/2 power. So I'm going to raise that to the 1/2 power, or take its root, and I end up with 60. 60 right there. Now, if we were to use tangent, the tangent of 33.4 degrees equals GJ, segment, that's measure, over 91, or 91 times the tangent there. Let's see how that works out. 91 times the tangent of 33.4. You see how that's, if you round that off, are you still going to get 60? Still going to work, isn't it? Okay? Just be really careful when, if you can use information you're given to find a missing piece, then I would do that. I wouldn't use information that I figured out for myself, just in case I did make a mistake on that bit, especially on the test, right? Okay. And then just be careful rounding. If I round off to 2 decimals here, I've got to know that my answer, if I use it again, is only going to be accurate to 1 decimal place. Okay. So I think sometimes on these problems they say round your answer off to 1 decimal. So you guys will round this answer off to 1 decimal, which is, this one's actually 40. That's why it looks like that. Then you use it to find a missing side, and you round it off to 1 decimal. But you have to remember, if you round this one off to 1 decimal, this one's only accurate to the ones place. Make sense to everybody? Yeah. So that's solving a right triangle. I think it's just taking stuff you already know and just putting it, more of it, into one problem. I don't think it's a big deal. Okay. So tomorrow, chapter review. We're going to save the last lesson in this chapter kind of for a separate thing. So today, chapter 9.6. There you go.